Hi guys, so today we are with our 3D geometry chapter for our WebG crash course, and we are going to deal with it at theory and question part separately. So I am going to tell you the theory part in gist. After that we will go to the question answer. Okay, otherwise it will take much time and we don't have that much time, right? So yes, let's start. So at first you can see in the introduction page that there is a graph in the rightward side. So that is how the three planes are there together. Okay, see, there is an intersection point, that is the origin. You must have seen the two-dimensional plane, but this is a 3D plane. Okay, so now let's move on to the actual theory. This was the just imaginative part, so let's start. Okay, so at first we can see the direction cosines of a line are cosines of the angles made by the line with the positive directions of the coordinate axis. Okay, so at first we need an angle. Okay, see here they have written cosines of the angles made by the line. So at first we need an angle and then we need an positive direction of an axis. Okay, so let's see this through a diagram. So see here we have three axes, x, y and z, and you can see there is a vector u vector coming from the origin. Okay, so that u vector makes different angles at the different axes. Okay, so it is making beta with the y-axis, alpha with the x-axis and gamma with the z-axis. So similarly this forms different angles, so this will also form different cosines because cos alpha, cos beta, cos gamma may have different values. Okay, so it is only said here that direction cosines of a line are the cosines of the angles made by the line with the positive directions of the coordinate axis. So for the cosines made with the x-axis, that is cos alpha, and with the z-axis it is cos gamma, and with the y-axis it is cos beta. That's it, nothing else with the cosines. And one formula is also there, that is cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, I will write it down when we will do the questions. You can remember it like this also. Okay, so let's move forward to the next one. Okay, the next point is if L, M, N are the direction cosines of a line. See, here it is told that, so here it is written L2 plus M2 plus N2, although it is not that correct. It will be L square plus M square plus N square is equal to 1, as I told you before. Okay, so never mind, we will write it down in the questions part. So let's move forward to the next point. Okay, the next point is the direction cosines of the line joining 2 points. Okay, it is joining 2 points P and Q. They may be anywhere in the space. Okay, oh yeah, one more thing, that in 2D coordinate system you can just consider a plane, but here we can consider any point in the space. Okay, so I think it's quite interesting for you right now. Yeah, so let's move on. Okay, so here it is that we are having P and Q, two different points. P is x1 y1 z1, Q is x2 y2 z2, and our so the direction cosine of a line joining 2 points. So the direction cosine for a line joining these 2 points, okay, that line would also have a direction cosine, and that direction cosine would be x2 minus x1 divided by pq, where pq is the length of that line segment from P to Q, and y2 minus y1 divided by pq, comma z2 minus z1 divided by pq. So these are the direction cosines. Okay, so the first one is with an x-axis. So as we can see here, we are getting that cos alpha term, then we are getting the y-axis, that is cos beta term, then is the z-axis, so we are getting the cos gamma term. Okay, so like this we can find the direction ratios for a line segment from for which yeah, we are having 2 points. From one point to another we are drawing a joint line segment, so in that we can find the direction cosines. Okay, so here like this we find the direction cosines. You may you should remember this one, because this is quite a visualizing thing, but yeah, it is quite interesting also, so you can do it, I guess. So now coming to the next part, where here see I have told you that PQ is equal to the line segment distance from P to Q. Okay, so we can find that, you know, in 2D vector also we have found out in the similar way we are doing here, that x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square whole to the power root would give us the length of PQ. Same formula like the 2D vector, but 2D plane or 2D coordinate system, but here we having the one another axis. So if we are considering just the formula, we just have to include one more, that is z2 minus z1 whole square. We have to add it, simple thing, right? So then we are having the direction ratios of a line are the numbers which are proportional to the direction cosines of a line. Okay, so you should remember this now, and after this point you will understand it also. Okay, so next point is, if L, M, N are the direction cosines and A, B, C are the direction ratios of a line, then L is equal to A by under root A square plus B square plus C square, M is equal to B by under root A square plus B square plus C square, N is equal to C by under root A square plus B square plus C square. Okay, so here it is quite understanding, I guess, that you are having the formulas right now. So for now you can memorize it, or just imagine it in a smaller way. Okay, at first you need to remember the previous point, that is the direction ratios of a line are the numbers which are proportional to the direction cosines. Okay, so they are proportional to the direction cosines, this much we know, and after that we are getting a formula through which we can relate the direction cosines and the direction ratios. So okay, so that is what they said in the previous point, that they are proportionals. So like this we can understand them in quite a better way. But okay, I guess you are getting a bit confused with this one, that direction ratios and direction cosines, but you know, we don't have much time to deal with it right now, so we can skip it for now and understand it later after our WebG. For now you just take a note of it and understand the remember the formula, and also remember that there is a relation. You must remember that there is a relation that is proportional of the direction ratios and the direction cosines. Okay, and after that if you see the formulas you can remember it for a while and use it in the questions if you need it. Okay, so the next one is the vector equations of a line that passes through the given point whose position vector is A and parallel to a given vector B is R vector is equal to A vector plus lambda V vector. Okay, so let's understand it, that vector equation of a line, we are making a vector equation for a line. Okay, for a line in the 3D geometry we are making a vector equation. Okay, so that passes through a given point through a position vector A vector. Okay, so that line must pass through a position vector that is A vector, and that must be parallel to the vector B. So we are getting here A vector plus B vector, A vector and B vector. So these two vectors are related to make the vector equation of a line. So for a vector equation what we need? A point whose vector is A vector and a parallel line to whose vector is B vector. Okay, so we will get a vector equation that is R vector, and it is equal to A vector plus lambda V vector. Lambda is given because the times we multiply it, the direction would not change. So as B is parallel to that line, it will not change, and lambda value can be given as we need it. Okay, for a definite vector equation we will have an exact value of lambda, or that lambda value can be changed for different lines. Okay, so now the next point is the Cartesian equation of a line that passes through 2 points x1 y1 z1 and x2 y2 z2. Okay, so this is quite interesting one, but for now you have to remember it. Okay, so this is quite a important formula also. Okay, so see, it is given x minus x1. See, x minus x1 divided by x2 minus x1. Okay, so just remember it for now, that x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. So what is this z1, z2 and z? Z is the term which we don't have an exact value. We are just using it as a variable, any value of z axis. Okay, and z1 and z2 are given here, the 2 points through which the line passes. Okay, so this is a formula, you must remember it. Okay, so the next one is the distance between parallel lines r vector is equal to a1 vector plus lambda b vector and a2 vector plus mu b vector. Okay, so see here, r vector is a equation of a vector, right? So we are having such 2 vector equations, and here we are using a1 and a2 because there are 2 different points but they are parallel. Okay, so here we are finding the distance between 2 parallel lines, as simple as that. Okay, we have done it in 2D, but if we have not done also, you just can imagine it, that there must be a distance between 2 parallel lines. Okay, so the b vector must be same because it gives the direction. Both are parallels, we are considering it in the same direction. Okay, so now r vector is equal to a1 vector plus lambda b vector and r vector is equal to a2 vector plus mu b vector. Okay, so the formula for doing it is the mod of, okay, b vector cross a2 minus a1 whole divided by b vector mod. Okay, so I think you know what is mod. So if we consider any vector, the mod would be the suppose b is equal to b1 plus b1 I cap plus b2 j cap plus b3 k cap. So mod b would be under root b1 square plus b2 square plus b3 square. Okay, so then we are coming to the equation of a line which is at a distance of d from the origin. Okay, so equation of a line which is at a distance d from the origin, and the direction cosines are normal direction cosines of the normal to the plane as L, M and N. Okay, so here the equation of a plane we are finding the equation of a plane and the distance of d from the origin. So that line plane has a distance d from the origin, and it the cosines that it makes with the normals of the plane. Okay, direction cosines of the normals of the plane are L, M and N. Then the equation of the plane would be Lx plus My plus Nz. Okay, so here you may not understand that direction cosines of the normal to the plane, but you can't understand it by just seeing it. Okay, you have to visualize it. So we will do it later in our questions when it comes. So for now we are going to the next point. Equation of a plane that cuts the coordinate axis a comma 0 comma 0 0 comma b comma 0 and 0 comma 0 comma c is x by a plus y by b plus z by c is equal to 1. So this is quite a general form for the line. Okay, you may use it in various ways. In many questions you will find a direct solution to it by just putting it. So it is quite a helpful formula. I will suggest you to remember it. It will be very helpful. Okay, so let's move on to the next one. Okay, so now two planes, that is a1x plus b1y plus c1z plus d1 is equal to 0, and a2x plus b2y plus c2z plus d2 is equal to 0 are coplanar. okay, are coplanar if, okay, this is not given, so this is equal to 0. Okay, why this is happening I am going to tell you in the questions part, but now for this one, this determinant would be 0. Okay, so we are here at the conclusion of a theory part, which is the distance of a point whose position vector is a from the plane r vector dot n vector is equal to d is, okay, so here r vector is a vector which is multiplied with a direction vector n cap. That r vector is a vector equation which is multiplied with the direction vector n cap, so dot product, and that would be equal to d. So this is a common representation of a plane. Okay, this is a common representation of a plane, and here we can find the distance of a point whose position vector is a. Okay, whose position vector is a, we are given a point whose position vector is a. Now we have to find the distance of that point from a plane whose equation is given to us. Okay, so that would be mod of d minus a vector dot n cap. Okay, so it is quite easy to remember. You just have to rearrange the equations that is given for a plane, and we have to put a vector in place of r vector and just do the mod. Okay, that is it. I'm just saying to remember it in an easy way. But see, I know that you have not understood all the equations that properly, but I will suggest you to memorize this for now. After that, as we finish our WebG, we will consider, we will surely do other classes on it and understand it in a deeply way. So I think you have noted down all the formulas. If you have not done, then I will also provide you the PDF which I am teaching you right now, so you can copy it from there also, but make sure that you do so. By not copying the formulas, it is a blunder, because you don't have time to keep it in schedule that you will do it later, or so on. So I will suggest you to do as you complete the sessions today, or while you are doing the session, you can pause the video and write this down. It will be very good. And okay, not continuing it much, I know you also understand the importance. So let's go to the questions part right now, and I think it's quite a long video this time, but what to do, we are starting a new chapter, right? So let's start. So I think you do not understood this one, so I thought to make a video on it. See, it was the point where it said that the direction cosines of a normal to a plane is L and M and N. So the equation of the plane would be Lx plus My plus Nz is equal to D, is equal to D. So D is a constant. Okay, don't worry about that. So it is told that a normal. So what is the normal here? It is actually the normal of an plane in the space. Okay, any one plane we are drawing, suppose this one, as I have drawn here. Okay, so this plane, now n is actually the perpendicular to this plane. Okay, but for this one it is just a vector. For this 3D geometry, it is just a vector, and it has gamma as the cosine angle with z axis, and alpha with the x axis, and beta with the y axis. So L is cos alpha, suppose cos alpha, M is cos beta, and the N is cos gamma. So this would form the equation Lx plus My plus Nz is equal to D. Okay, so this was it, and one more thing, that is they also said that we need an point A vector suppose, and a parallel B vector, that is this one. So like this we will have these two vectors and form a line, that is R vector. Now we don't have any such relations that we have to join it from here or here, but this A point must be here somewhere in R, right? And this B vector, this is parallel to this one, this distance would remain same. So like that, R vector is A vector plus lambda B vector. This was told. Okay, so I suppose you understand these two right now. So let's move on to the questions part right now, and we will do two questions for today because the video is quite lengthy, and the next ones we will do in the next video. Okay, so let's go. Okay, so here we are with our first question. So here, see the question. A straight line joining the points 1, 1, 1 and 0, 0, 0 intersects the plane 2x plus 2y plus z is equal to 10. So at first we have to write the equation of the line, then we will see that at which point it intersects, right? So for writing the equation of the line, we will just write the 2 points at first, that is 1, 1, 1 and 0, 0, 0. Now we know the formula, that is this one, x minus x1 divided by x minus x2 is equal to y minus y1 divided by y, sorry, this is x1, y1 minus y2 is equal to z minus z1 z1 minus z2. Sorry, I did a mistake. Okay, actually this is also true. Okay, but what you saw in the previous one, it is just the opposite, that is x2 minus x1, y2 minus y1, z2 minus z1. So I just turned all of them opposite, so it will be same, because the minus would cut, minus 1 that we are multiplying here actually would cut down for all of them. So basically the formula is same. You can see the formula from the PDF I will send you, otherwise this can also be the formula. Okay, so let's just put this. Okay, so here we are taking x, this one is suppose x1. Okay, this is x, this is the first one, and this is a second one. The first point and the second point, we are taking it like this. Then x minus 0 divided by 0 minus 1 is equal to y minus 0 divided by 0 minus 1 is equal to z minus 0 divided by 0 minus 1. Let's suppose this is equal to minus k, because we are just supposing, let this is equal to k. So for all of them I am saying that like this, suppose it will also be equal to k, minus k, this will also be equal to minus k, and this will also be equal to minus k, right? So like that, now we get the equation as x equal to y equal to z equal to k. So the point which we the point which we get here is p is equal to k comma k comma k. Okay, so let's suppose p is the point on the plane we are having here. Okay, so the equation of the plane is 2x plus 2y plus z is equal to 10. Now if this p lies on the plane, then we can substitute k, this k is k comma k comma k in x, y and z respectively. Okay, so 2k plus 2k plus k is equal to 10. This gives us as k is equal to 2, right? So now we can find that intersection point as p 2 comma 2 comma 2. This is a point of intersection. That is it. You have seen that how easy it is. You just have to put the formula and then just have to consider a common point k, or any point. Okay, that is, here we have written k, any like L, M, N, anything you can write, but L, M, N are generally taken as the direction cosine, so we have not taken it here. We have just taken k, just a constant. Okay, so this k, and now that k is we have thought it to be the point where it intersects the plane. Now after that we are substituting the values in the equation 2x plus 2y plus z is equal to 10, and that gives us as k is equal to 2. So the point of intersection is 2 comma 2 comma 2. Okay, so let's move on to the next question. You must copy it down, otherwise it will be very difficult. Okay, copied the you have copied the question, I guess. Okay, so here we are with the second question. Here we have to find the angle between two planes. Okay, this is quite a common question you can just think of. We are just having two planes. Suppose this is one of the plane. See how you can see it. We are having two planes. Now we have to find the angle formed by the two planes. So now you can say we are having four angles. So from the four angles we can say that here this angle and this angle would be equal by vertically opposite angles, and this one and this one, this would be equal by the same property. But now you can say that which one we are finding. Okay, now we will find the cos theta. Okay, now if the cos theta is positive, then we can say it is the acute one. I mean, see, this one is more than 90. Suppose this one is more than 90 and this is less than 90, then this is the acute one and this is the obtuse one. So either it will be acute or obtuse. On the properties based on acute and obtuse we will find it. Okay, so it is just a simple thing, and here actually we will find directly the theta, so you can see it that it is greater than 90 or not. If suppose we are finding pi by 3, and the answer options are also given as pi by 6 and pi by 3, we are having pi minus pi by 3, that is 2 pi by 3 and pi by 3 both, then both will be the answer. So don't worry about that. If they say that you have to find the acute angle, then you have to put pi by 3 as the answer. Okay, so let's start. Here we are having these two equations. Okay, at first we will write the direction ratios. Let's suppose this is the first one and this is the second one. Now direction ratios dr of first plane, direction vector. We will write direction vector. Okay, we will write direction vector, that will be quite better. Direction vector of first plane. Okay, so the direction vector of first plane is 1 comma 2. Okay, and similarly direction vector of second plane is 2 comma minus 1 comma plus 1. Okay, so these are two direction vector of these two planes. Now we have a formula. Okay, that formula is theta or cos theta. Suppose cos theta is equal to we generally take it as mod, you also take it as a1 a2 plus b1 b2 plus c1 c2 divided by under root a1 square plus b1 square c1 square plus under root a2 square plus b2 square plus c2 square. Okay, so what is a1 a2 b1 b2 and c1 c2? So these are, see, a1 is the direction vector of the first one. a1 b1 c1, these are the direction vector of the first line, that is here 1 2 1 1 and 2, and a2 b2 c2, these are the direction vectors of the second plane, that is 2 minus 1 plus 1. Okay, now this theta is equal to cos inverse this one. Okay, a1 a2 plus b1 b2 plus c1 c2 divided by this term. Just copy it down. Okay, now we will find it. We will just directly put the values, that is theta is equal to cos inverse 2 into 1 2, 1 into minus 1, that is minus 1, 2 into 1 2. Okay, so now this one, it is under root 1 square plus 1 square plus 2 square, so 1 plus 1 plus 4, that is 6. Same here, 1 square plus 1 square plus 2 square, 1 square plus minus 1 square plus 2 square, that is 1 plus 1 plus 4, that is root under 6. Oh sorry, this is multiply, sorry, this is multiply. Okay, so see, you have to write this formula down separately as I given the PDF. When you will write down the PDF part, write this formula also. This is multiplication, that was a silly mistake, sorry, and this is also multiplication. Okay, so this would be cos inverse equal to, sorry, theta is equal to cos inverse 2 plus 2 4 minus 1, that is 3 by root 6 into root 6, that is 6, that is cos inverse 1 by 2, that would be pi by what, pi by 3, yes, 60 degree. So see, here we are finding pi by 3. Okay, so if the option is also given that 2 pi by 3, that is also correct, because as we know that one angle will be acute and one angle will be obtuse, so we will get two angles here, right? So both pi by 3 and 2 pi by 3 both will be right, so don't worry about that, as you will get the options